In this article, I'm going to discuss the minimum swaps 2 problem from HackerRank's interview preparation kit and explain a fast ON solution to it. Question. In this question, we're given an unsorted array of consecutive integers. We need to find out the minimum number of swaps, the process of interchanging the position of 2 values in the array, required to sort the array in ascending order. It is further noted that the array will only contain consecutive integers from 1 to n without any duplicate. Explanation with example. Let's consider the following example. Suppose the input is 4, 2, 5, 1, 3. It contains consecutive integers from 1 to 5 without any duplicate. Thus, this is a valid input. Now, let's refer to the table below to check what's the minimum number of swaps required to sort this array. Original input, 4, 2, 5, 1, 3. Thus, we find out that for the inputted array, the minimum number of swaps required to sort it in ascending order is 2. Minimum swaps 2 solution logic. As mentioned in the question, the array contains consecutive integers from 1 to n, where n is the size of the array. Thus, we can accurately predict the contents of the array when arranged in ascending order, if its size is known to us. For example, if n equals 7, we can for sure say that the sorted array would be 1, 2, 3, 4, 5, 6, 7. This is possible only because the numbers are consecutive and there are no duplicates present. If that wasn't the case, we would have to use a sorting algorithm first, which would take at least O n log n time complexity, which would be too slow considering the constraints of this problem. Now that we know that in its sorted form, the array would contain 1 in its 0th index, 2 in its first index, 3 in its second index, and so on, we can scan through the inputted array and check if the values of its indices match with the values of the respective indices in the sorted array, or not. If it doesn't match, we can swap it with the value that is supposed to be there in its sorted form, and count the swap. We need to store the index position of the elements in the unsorted array so that they can be used while swapping, as shown in the example below. Solution logic explained with an example. Here's an example. Let's consider the input to be 4, 1, 3, 2. We store the index position of each element in a different array called pos. It is stored in a way such that pos n equals the index at which n lies in the unsorted array. For example, pos 4 equals 0, as 4 lies in the 0th index of the unsorted array. The pos array can be made of size n plus 1 for our convenience. In that case, the 0th position of pos will always be empty, or 0 as we wouldn't need to access it. Thus, pos 4 equals 0, pos 1 equals 1, pos 3 equals 2, and pos 2 equals 3, as 4, 1, 3, and 2 lie in the 0th, 1st, 2nd, and 3rd indices of the unsorted array, respectively. So, we get pos equals 0, 1, 3, 2, 0. In its sorted form, the inputted array would be 1, 2, 3, 4. Now, we traverse the unsorted inputted array from the beginning till the end. At index 0, we have 4. But the value that is supposed to be there in the sorted form is 1. Thus, we swap 4 with 1, which is at first of the current unsorted array. We get this position from the pos array. Pos 1 equals 1, and get the updated array as 1, 4, 3, 2. Updated array equals 1, 4, 3, 2. We also update the pos array to store the updated positions of the elements of the current unsorted array. Thus, updated pos equals 0, 0, 3, 2, 1. No. Of swaps equals 1. Now, at index 1, we have 4. but the value that is supposed to be there in the sorted form is 2. Thus, we swap 4 with 2, which is at current position 3 of the unsorted array. We get this position from the pos array. Pos 2 equals 3, and get the updated array as 1, 2, 3, 4. Updated array equals 1, 2, 3, 4. We also update the pos array to store the updated positions of the elements of the current unsorted array. Thus, updated pos equals 0, 0, 1, 2, 3. No. Of swaps equals 2. Now, at index 2, we have 3. It matches with the value that is supposed to be there in its sorted form. So, no swapping is done. Array remains the same. Pos remains same. At index 3, we have 4. It also matches with the value that is supposed to be there in its sorted form. So, no swapping is done. Now we're finished traversing the array, and on the way, we have also sorted it and counted the number of swaps we made. So, we now have the required answer as 2. Code solution. The code solution to the HackerRank interview preparation kit minimum swaps 2 problem, using the same logic as explained above, is provided in the description below. The link to the code in Java, C, C++, and JavaScript, Node.js, is provided in the description below. Result. I hope this article helped you understand the minimum swaps 2 problem and its solution. If you have any doubts regarding this question or its solution, feel free to comment down below. I will try my best to help you out. Kindly consider sharing this article if you found this helpful. Happy coding. FAQs. ON, where n is the size of the input array. Java, C, C++, and JavaScript, Node.js.